Okay, 2023, ADMA paper 2, question 12. The curve y is equal to e to the power 4 minus 3x and y is equal to e to the power x minus 8 intersect at a point P. Find the coordinates of P. So coordinate geometry tells us that to find the meeting point of two equations, you have to solve them simultaneously. So let's solve these two equations simultaneously. Y is equal to e to the power 4 minus 3x and y is equal to e to the power x minus 8. So I will use substitution method because it's the easiest. You can also use elimination by writing them like this and then subtract. So where you have y, you can just substitute the y value there. So you can say e is equal to x minus 8, which is equal to e to the power 4 minus 3x. And then since the bases are the same, you can conclude that the powers are also the same. So since e is equal to e, then you can say x minus 8 is exactly the same as 4 minus 3x. Let's solve for x. You can take the x to the other side. Then you have 4, you take the 8 to the other side, this plus this, we have 4x, this plus this, we have 12, so that your x is 3. And then you can use this and any of the two equations to solve for y. So I'll use this one. I think it's much easier for me. So you have, where you have x, just put your 3. The answers will still be the same whichever equation you use, by the way. And then this is calculator work. So I can just have my e raised to the power negative 5. So this one will be, this is a very small number. So I think I'll just leave it like this. But you can get an estimate from your calculator by punching it in. But as you can see, this is like 6.7379 and some numbers multiplied by 10 to the power negative 3. So that's 0.00, and then you have 6, 7, and these other numbers. So the meeting point of these two equations is 3, e to the power negative 5. You are allowed to write it like this. It's actually better because this is exact. And then on part B, sketch the graph of y is equal to natural log x plus 3 for the domain negative 2 x to 4, taking values of x at unit intervals. So before you do anything, you can make a simple table like this, which will give you ideas of your domain and your range. Of course, the domain has been given, but we are not very sure what our range is. So we can use this to find our range. You may not need all the points, but I'll use them anyway. So when x is equal to negative 2, we have y is equal to negative 2 plus 3 there. So this is x, this is y. So that means we have a 1 here. Because this plus this, actually this is 0. This plus this would be a 1. And then ln 1 is 0. So we have a 0. This will be our smallest y value, since this curve is something like this. So our highest y value will come from that. Then when x is equal to -1, so you put your -1 there, you have a 2. So this will be ln 2, which is equal to approximately 0.7. When x is 0, you have ln 3. So you have ln 3, which is approximately 1.1. When x is 1, you have ln 4. I'm just putting my 1 there and adding it to 3. So this will give you about 1.4. And then when your x is 2, so 2 plus 3, you have a 5. So you have ln 5, which is equal to 1.6. So this graph is more of the x-axis than it is of the y-axis. So on when x is 3, you have ln 3 plus 3, which is 6. So this will give you approximately 1.8. Finally, we have our highest point, which is 4. Then 4 plus 3, you have a 7. Then 7 is 1.9. So you can have your y values from 0 to somewhere 2. And then you can make a sketch. So I won't make my graph like this. I'll make it like this. This is even better for my screen in landscape mode. So you don't need a lot of numbers on the y-axis. You only need like 1 and 2. Maybe you can even have 1 here and 2 there if you want. And then we've been given this condition actually. So taking values of x at unit intervals. So at unit intervals, you'll be taking them like you have, if this is your -2, then your -1 will be here. Nothing like skipping, nothing like, you just want to take them at unit intervals in short. So if this is my -2, 1, this will be 0, 1, 2, 3, 4. Okay, so this will work. So we can just draw our x-axis here. So we have -2, -1, then we have 0, 1, 2, 3, and 4, like this. And then we can draw our y-axis here. So x, make sure you label your axes. So I'll put my 1 there and my 2 there. We have no restrictions on the y-axis. The only restriction we have is on the x-axis, where you are required to take the x values at unit intervals. So now let's plot these points. So we have -2, 0. This point is here. Then we have -1, 0.7. So -1 is here. And then my 0.7 will be, this is my 5, 6, 7 is there. And then you have 0.1. My 1.1 is there. Then we have 1.4. 1.4, 1, 2, 3, 4. My 1.4 is there. So as you can see, this thing is moving in this direction. So when x is equal to 2, y will be 1.6. So my 1.6 is somewhere there. Then 3, 1.8. 1.8 is there. 4, you have 1.9. So you may not even need all these points. Just the starting point, the x-axis, the y-intercept, and the last point will be enough for you to know the curve, provided you know what the shape looks like. So you have something like this. And then you can name it y is equal to ln x plus 3. Then you are done. Let's move on to part C. So part C is saying find the equation of the straight line which must be drawn on the graph of y is equal to 3 minus e to the power x to obtain the solution of this equation. So I'll manipulate this to obtain this. So your job here is to just mess around with what you have to get what you want. So since we don't have an e in here, we don't have a natural log in here, I'll get rid of this thing and introduce the e. Remember, this is the same as, ln is the same as log e of whatever you have there. So now to get rid of the log or the natural log, I'll write this in exponential form. If I was to read this in English, this would be to what power should I raise e to get this? And the power is this. So in mathematics, this is like saying e to the power x is equal to the square root of 2 minus x. So far, so good. We have an e, but it's not the e we want, because this is e to the power 2x and then this is e to the power x. So to make this e to the power 2x, I can square both sides. Remember, whatever you do on the left hand side must be done on the right hand side too. So this one will be e to the power 2x, and then this will take care of the square root, so that you have 2 minus x. And then now we are getting there, but we are not quite there yet. We want e to the power 2x to be negative, so I can just take this to the other side and bring everything else this side. So or maybe I can just take the x this side, leave the 2 here, and then we have negative e to the power 2x. So now I want a negative 3 here, not a 2. I want a positive 3 here and not a 2. So what I can do here is I can either add and subtract a 1, or I can add the 1 to both sides. So if you decide to do this, then this one will be added to this so that you get that, and then you can take the 1 to the other side. So this is what I'll do. I'll just add a 1 to both sides. So this one will be x plus 1, and then 1 plus 2 will be 3 e to the power 2x. So this is exactly what we want, as you can see. So since 3 minus e to the power 2x is y, we can conclude that this thing here is a y. So that means y is equal to x plus 1 is the equation we are looking for, and you are done.